Hello class, today what we're going to do is talk about how to prove that lines are parallel. In the previous lesson we saw that if we had parallel lines cut by a transversal, then corresponding angles were congruent and same side exterior angles were supplementary and things like that. But for those to work, we have to know that the lines are parallel. So how can we prove that lines are parallel? And what we're actually going to do is use the converse of all of those theorems we talked about last time. So last time we talked about the corresponding angles theorem, which said that if you had two parallel lines cut by a transversal, then the corresponding angles would be congruent. The converse, if you remember, that you take your conditional statement and you switch the orders around. All right? So what this says is that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines must be parallel. So the corresponding angle theorem says if line J is parallel to line K, then 2 has to be congruent to 6. The converse says that if angle 2 is congruent to angle 6, then line J must be parallel to line K. All right? So it depends on what is it you're trying to prove. If you're trying to prove that the angles are congruent, then you need to know that the lines are parallel, and you will just use the corresponding angles theorem. If you're trying to prove that the lines are parallel, then you have to know that the corresponding angles are congruent, and so you use the converse of the corresponding angles theorem, or the corresponding angles converse. All right? So, for example, what we can do with this is we can find some value of x that would make line M parallel to line N. All right? Well, if you look at these angles, we see that these are corresponding angles. So if I can prove that this angle is congruent to the 65-degree angle, then that will prove that M is parallel to N. So what value of x would make this congruent to that? Well, if they're congruent, then the measures have to equal, right? So that's what we're going to do. We set the measures equal to each other. So 3x plus 5 degrees has to equal 65 degrees. And this is according to the corresponding angles converse. We want to make these two corresponding angles congruent to each other. Then we just solve this. Subtract 5, divide by 3, and we end up that if x equals 20, then M and N are parallel. All right? Now that was the corresponding angles converse. We had 5 different angle relationships, and the converse to each of those will work to prove that lines are parallel. So for the alternate interior angles converse, we have to show that alternate interior angles are congruent, then our lines will be parallel. Alternate exterior angles converse, the same thing. The alternate exterior angles have to be congruent for the lines to be parallel. Now for consecutive interior angles, we are not trying to show that they're congruent. For consecutive interior angles, they have to be supplementary, and that will prove lines parallel. Or you may see this as same side interior angles. Right? And these same side exterior angles, if they are supplementary, then the lines are parallel. Right? So for corresponding alternate interior, alternate exterior, the angles have to, if the angles are congruent, then the lines will be parallel. For consecutive or same side interior angles or same side exterior angles, then the angles need to be supplementary for the lines to be parallel. All right? Okay, so what we're going to do here is prove that if these two lines are cut by a transversal so that alternate interior angles are congruent, that the lines are going to be parallel. So we want to prove the alternate interior angles converse. All right, so we know that angle 4 is congruent to angle 5. So we know that our alternate interior angles are congruent. What we want to do is prove that that makes G parallel to line H. Okay, so we're going to do this in a 2-column proof. So we'll start with what we're given. Angle 4 is congruent to angle 5. So what else do we know about angle 4 and angle 5? Well, let's see. Angle 4, they've given us angle 1 here. So angle 4 and angle 1 are vertical. Angle 5 and angle 1 are corresponding. So we've got some relationship going on with angle 1 and 4 and 5, so let's do something with that. So we'll just start with 4 and 1. The 4 and 1 are vertical angles, so that means that angle 1 and angle 4 are congruent to each other. vertical angle congruence theorem. And so let's see, what can we say about 1 and 5? We cannot say that 1 is congruent to 5 with the corresponding angles theorem, because for that we have to know that G is parallel to H. We don't know that yet. We're trying to prove it. But what can we say about 1 and 5? Well, if we look at this, angle 1 is congruent to angle 4. Angle 4 is congruent to angle 5. So we have two angles both congruent to the same angle. That means those two angles must be congruent to each other. This is the transitive property of congruence. All right? Two things congruent to the same third thing, so those first two things must be congruent to each other. All right? So now we know that angle 1 is congruent to angle 5. So what we can say is, hey, corresponding angles converse, these must be parallel. Those are congruent, so our lines must be parallel. Corresponding angles. All right. Last theorem of this lesson is the transitive property of parallel lines. This is a lot like the transitive property of congruence or the transitive property of equality. If you remember, we just used the transitive property of congruence. We said, hey, if these two angles are congruent to a third angle, then those first two angles must be congruent to each other. Transitive property of parallel lines is pretty much the same thing. If you have two lines parallel to a third line, then those two lines must be parallel to each other. So here we have line P is parallel to line Q. Line Q is parallel to line R, so both P and R are parallel to Q. P must be parallel to line R. Right? An example of that would be the United States flag. Right? Each stripe is parallel to the stripe immediately below it. So how can we prove that stripe 1 is parallel to stripe 13? Well, stripe 1 is parallel to stripe 2, and stripe 2 is parallel to stripe 3. So by the transitive property, stripe 1 is parallel to stripe 3. And stripe 3 is parallel to stripe 4, and since 1 is parallel to 3, then stripe 1 is parallel to stripe 4. And we just keep going on and on and on until you've proven that stripe 1 is parallel to stripe 13. You just work your way down. Right? And that's the transitive property of parallel lines. All right, last thing. So what we have here, we have that line P is parallel to line Q. Line Q is parallel to line R, and we want to find the measure of angle 8. All right? So I'd like you to pause the video and find the measure of angle 8. And make sure that you explain your reasoning step by step. You got to be able to back it up. All right? Prove that you're right. So pause the video, work this out, and then come back. Alright, so let's see what we've got. P is parallel to Q. Q is parallel to R, so that means that P is parallel to R with the transitive property of parallel lines. Alright, so now I've got P parallel to R, and I've got my two angles here. One of them is over there on line P, one of them is down here on line R. What position are these in? What is the relationship between these two angles? Well, they're on the same side of our transversal S, so we've got same side, and they are on the outside of these two lines that we cut, outside of P and R, so they are exterior on the same side, so same side exterior angles. What do we know about same side exterior angles? Well, if the lines are parallel, which we have proven that they are, we know that same side exterior angles are supplementary. So we can say that the measure of angle 8 plus this 115 degrees equals 180 degrees because they're supplementary. And so we just subtract 115 from both sides. We know that the measure of angle 8 is 65 degrees. Right? And that's basically it. So just in summary, if you are proving the lines are parallel, then you need to use the converse of all those angle theorems we had before. If you know the lines are parallel and you want to prove them congruent or supplementary if they're on the same side, then you use the regular theorems, the angle theorems. Alternate interior angle, same side exterior angles, use those to prove that the angles are congruent or supplementary. If you know the lines are parallel. If you don't know the lines are parallel and you want to prove the lines are parallel, then you use the converse. All right? So converses prove the lines parallel. The actual theorems prove angles congruent or supplementary. So I hope that helps, and I will see you next time.